All right, let's integrate x plus 1 over x cubed minus 4x squared plus 5x minus 2. So we want to solve this by using partial fraction decomposition, but it's not clear what we need to factor on the denominator. So when that's the case, you want to try to see what you can plug in and see what value of x makes it equal to 0. So for this, we want to use what's called the rational root theorem. So we're going to be looking at you look at 2 and 1. So basically look at the constant over the leading coefficient, and then you look at all possible factors for these. So we have basically plus or minus 2 or plus or minus 1. So those are 4 options. It's easier to start with the easier option by plugging in x equals 1. So if I plug in 1 here, we have 1 cubed minus 4 times 1 squared plus 5 times 1 minus 2. That's going to equal 0, which means x equals 1 is a factor, or x minus 1 is a factor. So I can use synthetic division to figure out what are the other different factors. So we're going to put in the numbers. So this drops down. We do 1 times this 1 up here. Is 1, and then when we add it is negative 3. So we do negative 3 times 1 is negative 3. Add, multiply by 1, and get 0. Because the remainder is 0, that means it's a factor. So this gives us x squared minus 3x plus 2 on the bottom. And then remember, we still have x minus 1. And we can factor out x squared minus 3x plus 2 as x minus 2, x minus 1. So I can rewrite this as just x minus 1 squared times x minus 2, since there are 2 factors of x minus 1. So then I can write this whole thing. So x plus 1 over x cubed minus 4x squared plus 5x minus 2 is the same thing as x plus 1 over x minus 1 squared times x minus 2. In order to do partial fraction decomposition, we have to split this up into multiple fractions. So first one will be just x minus 1. Then we move on to x minus 1 squared. And then finally x minus 2. And so now we can multiply both sides by x minus 1 squared times x minus 2. And we get this. So now we just need to plug in different values to solve for a, b, and c. A good choice is x equals 1. On the left we have 2 equals. The first and last term are going to cancel. And we have b times negative 1, which is negative b, which means b is negative 2. Plug in x equals 2. On the left we have 3. The first 2 terms cancel, and we're left with the last one, which is just c. And then finally, we want to solve for a, which means we can plug in anything we want. But to make things easy, let's plug in x equals 0. So if 0 plus 1 is 1, and then we have 0 minus 1 times 0 minus 2, that's positive 2a. And then 0 minus 2 is negative 2 times b. It's negative 2 times negative 2. Plus c. c is 3 times 0 minus 1 squared is just 1. So we can simplify. We have 2a plus 4 plus 3 is plus 7. 2a is equal to negative 6, which means a is negative 3. So now I can rewrite this. First one is a over x minus 1, which a we said is negative 3. The next one is b over x minus 1 squared. That's negative 2. Last one is c over x minus 2. c we said is 3. So we integrate, we have negative 3 natural log x minus 1. and then plus 2 over x minus 1. This is a plus, so that's plus 3 ln of x minus 2 plus a constant c. And if you want, you can combine the natural logs, but we'll say this is our final answer.